What is our equation of just a generic line? What is our generic?
Y equals
mx plus b. Good. So y equals mx plus b. So any line that we've dealt with in the past has always had this equation: y equals mx plus b. That m, what does that stand for? What did that be? Your intercept. So your slope-intercept form is another name we call it. How do we calculate the slope from 2 points? y2 minus y1, x1, divided by x2 minus x1. So y2 minus y1, that's 2 minus 4. x2 minus x1, that's 8 minus 5. Pulling those from our coordinates, our points. 2 minus 4 is negative 2. 8 minus 5 is 3, so negative 2/3 is your slope. Are we okay with this from previous couple weeks ago?
Yeah.
Cool. So we're going to continue talking about lines a little bit. I know we talked about data and statistics for maybe a month or so. But we're going to pull back into lines. We're going to talk about a couple new things involving lines, and then we'll talk about what happens when we have multiple lines when we get back from spring break. But right now we're going to talk about this week. We're going to talk about Thanksgiving break. I'm sorry, not spring break. That's in the fall. So we're going to talk about 2 new things with lines, and then we'll utilize that after Thanksgiving. So if you had a graph, how can we go about finding the equation of this line from a graph? What are some things we need to look for in order to find the equation?
The y correlation.
So in order to find what we talked about in the last slide, we said it's slope-intercept form. So we need to find that slope, and we need to find that intercept. What is that intercept again? Yeah, it's b for my equation. Well, what is the intercept from a graph? What does that intercept mean?
Oh, it was 2 points. So 2 points. Let's move the line touches.
So our y-intercept, our b, that's where our line crosses that y-axis. So once again, my y-axis, that's my vertical axis, my up and down. So where my line crosses my x-axis, or my y-axis, is at this point, which is 0, 2. Which of those values am I going to use for my b? 0 or 2? 2. Remember that 0 represents the x-coordinate, which is just 0, but my y-coordinate on my y-intercept is 2, and that's going to be your b. The other value I need to know is that slope. How can I find the slope from a graph? All right, so if we're trying to find the slope from a graph, we need to find 2 points on that graph. So I already have 1 point, my y-intercept. Another point that looks like it's a nice crossing point, we'll say that one looks good because it's got a nice spot. If we're to find our slope, we looked at the rise and run. Good, Joby. So my rise is 3, my run is 1. So my slope for this would be 3 over 1, or just 3. So in order to find the equation from a graph, look for that y-intercept, look for that slope. Now, lines, what do we know about their slope? If I looked for the slope of the line way up here at the top, what am I going to find? What was that?
Same thing.
Same thing? What if I look for way down here? Same thing, I'm still going to get that same slope.
Not negative. That would just be.
So my numbers might be negative down here, but my slope is still always going to be 3/1. We have that constant slope. The slope never changes. That whole line from the top to the bottom, even though they don't have at any side, they're always going to have that constant slope. It's always going to be a slope of 3 in this case. Now, if we think about lines, they're made up of points. It's just a point after 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 a point, just over and over again, all the way. And that makes a line. And those slopes are, or all those points are increasing by that specific slope. They might not all go over 1 and up 3. But if I went over a centimeter, how much does that mean I go up? And so forth. So because our line has a constant slope, and because it's just made of thousands and thousands and infinite numbers of different points, we don't only need a slope and an intercept to make an equation of a line. So what happens if I had a graph of a line that didn't cross the y-axis? Though it just didn't have the y-axis on the picture. Would I be able to find the equation from that? I mean, if you manipulate it with a little bit of algebra, there are ways. But if you don't see the y-axis on a line, for example, if we had this line, we don't know where that thing touches the y-axis. We can take a guess, but we don't know. We could use some algebra, we could find it out with a little bit of work. But because it's hard to find the equation of a line without the y-axis, our slope-intercept form isn't the only form of a line we have. It's important. It's probably the most common form we'll ever use, and it's the one you'll see used in science and everything like that. But it's not the only form of a line we have. We have 2 other forms that we're going to learn about this week. So the first one we're going to learn about today is called point-slope form. So point-slope form, rather than being used a slope and an intercept, we still will use a slope. So your slope is going to be that m. But rather than using your y-intercept, we use just any point on that line. So any point xy, whatever that point might be, it might be right here on my line, it might be over there on my line, it doesn't matter where it is. As long as it's on the line, you can use it for point-slope form. What this means, if I have infinite number of points on my line, I can create an infinite number of equations. So with point-slope form, we can create the equation of the line, but your line might not always be the same. If you chose a different point than someone else, they'll still be the equation of the same line, but they might not look the same, and that's okay. So point-slope form, it's not used as consistently just because depending on which point you would choose, it might look different even though they're the same lines. So we don't use it as often because of that, but it still does show up and it still has its merits, especially with geometry. They use point-slope form a lot. So how we write point-slope form though? It's going to be y, just like in y equals mx plus b. This green y1, that is going to be your y coordinate of whatever point you chose. So on your line, you can choose whatever point. That point has an xy coordinate. That y coordinate of that point, that is going to be your y1. Your n is going to be your slope, just like normal. And then in parentheses, x minus x1. Your x1, that is your x coordinate from your point. So this is a new way of writing lines. Just like how we write the equation of a line as y equals mx plus b, this is a new way that you can write a line. Point-slope form, y minus y1 equals m, parentheses, or quantity, x minus x1. So it's a little bit messier, there's a little bit more involved, but it can be useful and it can be helpful to be able to change between slope-intercept or point-slope form. And so we're going to practice just being able to create equations of lines in this form and being able to recognize it. One of the main things to recognize, it's always minus your coordinate. So it's x minus x, y minus y. So whatever your coordinates are going to be, you're always going to have to subtract them. So if it's a negative and you subtract a negative, you'll have to add them. So we'll see some examples of that and what we'll have to do on those problems. Are we okay with this point slope form at the moment? Do you understand what each piece means? All right, so we're going to jump into actually using this.
Are you recording?
Yeah, it should be on. All right, so we want to write the equation of a line, or we want to write an equation of a line in point slope form that passes through the point 324 and has a slope of negative 0.6. So we just want to fill in our spots in this point slope form. So the things that are never going to change is it's always going to be y equals and then x. We just need to fill in what is that y1, what is our slope, and what is our x1. So if I look for my coordinate, 24 is my y1. So I'll have to do minus 24 because we're always subtracting. So my slope of my line, my m, is negative 0.6 or negative 0.06. And then my x, I'm told is 3, so I'll have to do minus 3. And that would be the slope in point, or that would be the equation of my line in point slope form. So it's really just being able to figure out which piece goes where from your information, from your point, and then being able to write it. So the reason this becomes helpful is if you have minimal information from a line. We learned how to find the equation from a graph. We learned how to find the equation of lines from 2 points. But if you just have a single point and a slope, rather than having to do a lot of algebra to create the equation of a line, we can just jump straight to this form. That way you don't have to solve for the y-intercept and do a lot of work to be able to figure out what is the equation of my line, but we can just write it in this form instead. Are we okay with how we were able to write that? Do you think you can try 2 more? Or do you want to see another one on your own? Or another one together? You want to try the 2 on your own? All right. If you have questions, let me know. What did we find for our equation of our first one? What was the equation of our first line? Yes, good. So y minus 5 equals 7, quantity x plus 1. Thing to notice, it's x plus 1 because anytime you minus by a negative, it becomes a positive. Good. What did we find for our second one? So, on this one we have 0 as our x coordinate. So we subtracted by 0. Is subtracting by 0, is that doing anything? So I could really rewrite this and not have that 0 in there at all, not have that parentheses in there at all because the parentheses would just be around the x. And it wouldn't change the problem, it'd still be correct. It wouldn't be an issue. So if you have a 0, you don't have to write that in there because it's not changing the problem. It's not needed. So this could be the same as y plus 5 equals 3/4 x, and that would work as well. It's good. Are we okay with these? Any other questions on writing the equation from the slope or the point? All right. So today we're just going to focus on being able to write this equation, being able to discover how can I find the equation of the line just from different situations. So there are probably situations that we might have seen with our y-intercept form that we might have learned before, but we want to be able to write them in point-slope form now, just from these different situations. So if I have this equation, or I need to find the equation of the point-slope form from this table. So I have a table, an xy table that represents some of the values that this line meets at some point. I need to find the equation of this in point-slope form from this table. So, just as the name suggests, I need two things. I need a point, and I need a slope. Do I have any of those to start with?
Yes.
What do I have?
4 points.
I have a point. I have lots of points. I have 4 points. I have plenty of points to choose from. So I have point down. I have that good. So it doesn't matter which point you choose. It's up to you. But we still need to find slope. How can I find slope?
You plot the points.
What if I don't have a graph though?
You make a graph.
Do I want to like spend that time like making that graph and getting my points right?
Yes.
Can we find the slope just from between 2 points?
No.
Or just
No. Have to make a graph.
so if I just chose 2 of these points, such as -4, 13, and -2, 8, can I find the slope between these two? y2 minus y1 over x2 minus x1 minus x1 will be positive. So 8 minus 13 is -5. -2 plus 4 is 2. So I have -5. -5. So we have our slope. We have a plethora of points to choose from. And so honestly, you could write 4 different equations, one using each of these points, and they would all be correct. There's not one that's correct, or there's not one that works better than the others. So it's really whatever point you choose. So I'm just going to choose this first one. But understand that it is possible to create an infinite different number of points, an infinite different number of lines based off what you have. So what would the equation look like if I use this first point?
Y minus 13 equals -5 over 2 in parentheses between x plus 4.
Good. So it's y minus my y coordinate, which is -13. So minus 13 equals my slope of -5 over 2. Quantity x minus my x coordinate, which is -4. So I do plus 4. And that would be one possible equation from this table. Once again, I could use any of these points, and I'd still have a correct equation. Because all you need is a point on your line and a slope of your line, and that works. All right. So your job, I want you to make 2 equations, 2 different equations from this table. Once again, your domain is your x value, your range is your y value. So find the slope, create 2 different equations using 2 different points, just like what we did on that last problem.
Like Africa.
So what did we find for the slope of our line? 2. Once again, you could have found that using whatever points you wanted. 6, 5, 3, -1, whatever points, it doesn't matter. y2 minus y1 over x2 minus x1 gives you a slope of 2. Someone give me one equation they used. Actually, a graph. Equation.
Oh, never mind. Actually, it's a graph. Never mind.
Y plus 2 equals 2. Parentheses, x plus
Good, so you used 3, -1. Someone give me another equation using a different point. Why, say that one more time? So y minus 11 equals 2, quantity x minus 9. Good. But once again, you can create as many equations as you do have lines. As long as you can find that slope, you can have a point, you can create the equation of it.
That means it's 101.
Beat it every hour.
Alright, if we were to create an equation from a graph and point slope, what would you do? How can you find the equation of a graph?
Find 2 points.
Find 2 points.
Which has each 2 points are.
Alright, we have 2 points. What can I do with those 2 points? So we can do rise or run. You can find the slope using the coordinates, but we can just do rise or run and now save us the trouble. So we get our slope of negative 2 over 3. From here, we can choose either of our points, either of our coordinates. So this one's 3, 0. This one's 0, 2. It doesn't matter. You could create a point for each. You could create a line for each. Well, all we have to do is just y minus 2 equals negative 2/3 x minus 0, or you could go off, leave the 0 off. It doesn't matter. But if you can find the slope of your line, just pick a single point on that line, and then that is use that as your point for your equation. Because once again, in order to create this line, in order to create this equation, the only things you need is what's in the name, a point and a slope. So you just need those 2 things. Alright, I think this is the last thing we're going to do today. We just want to be able to graph. So, in order to graph, I know you don't have graph paper, so I know you won't be able to do this along with me. I apologize for that. In order to graph in point slope form, we need to first plot your point. Just like what we would with y-intercept or slope intercept form, you would plot your y-intercept and you can go from there. We can do that exact same thing with our point. So looking at this equation, what is the point that I used in this equation? So it's always minus that value. So if I have negative 6 here, I know it's going to be positive 6. Positive 2. So positive 6, positive 2. So if I look for 6, 2 on my graph, I can place my point there. Now what is my slope? 2/3. So 2/3 tells me that I need to have a rise of 2 and a run of 3. So when we graph our lines, we would rise by that slope and then do that run. So up 2 over 3, and then I could keep doing this in both directions to get my line. So that's the same as down 2 to the left 3, down 2 to the left 3, and that would be our line. I apologize that you guys don't have graph paper to do this along with me. But all you have to do, find that coordinate, plot your point, and then just do your rise and your run. Are we okay with this?
Yeah.
And that's where we'll let it for good.